Okay, so I shared with you how you're going to give me the answers. But before we do that, let's work out some problems together. So I sent this to you. I sent this to you, and this is our assignment for today. So let's just work on this assignment together. We'll just do a few of these till about uh 1:15. I'm sorry, 1:50, and then you'll have the next hour to do the quiz. Okay, so very quickly. Of course, this problem just requires you to convert from Celsius to Fahrenheit. And how do we do that? We say, hold on. Okay, we say I'm given a temperature in degrees Celsius. So temperature Celsius is given 20 degrees Celsius. But I want to know what that temperature is on the Fahrenheit scale. So all I do is I remember that temperature Fahrenheit is equal to 9/5 temperature Celsius plus 32. So my calculator, what do? I take 20 and multiply it by 9, divide it by 5, and add 32. So let's do that very quickly. Take 20 multiplied by 9, divide it by 5, get that answer, and then add what? 32. When you do that, you get exactly 68. So that means then that you're going to choose C. If this was our quiz, you would have in your answer key, you would have 1, you put a C like that. Now we go to 2. Okay. Now 2. In 2, we're given degree Fahrenheit and we want to find degree Celsius. So what do? Same thing, but different equation. Because now we're given the temperature on the Fahrenheit scale, which is 172 degrees Fahrenheit. So now my equation, because I'm looking for the Celsius temperature, now I say temperature Celsius is 5/9 parentheses temperature Fahrenheit minus 32. So what do? First, I take 172 and I do what? Subtract 32. Then I multiply that answer by 5 and divide it by 9. And when I do that, I get 77.7. So 77.7, I'm going to choose 78. So those type problems, you can just do it in your head on your calculator. That's why I say have your calculator in front of you. Now, one like number 3, it says, at which of the following Celsius temperatures will a Fahrenheit thermometer show the same reading in degrees? Okay, so that means you gotta check all these out to see if you get the same number. Well, let's just plug it into the easiest equation, which is the first one. Okay, so we say what? Temperature Fahrenheit is 9/5, and my answer here, temperature Celsius is -40. And then I'm going to add what? 32. So when I do that, what do I get? I've got -40 times 9, and I divide that by 5, and I get what? I get 72, -72. So when I get -72 here, and I add to that a positive 32, of course, I get what? A -40. I'm looking for a degree Fahrenheit. So this is what? Degree Fahrenheit. So the first one shows us what? The right answer. I put that one as number 1 because I want to spend a lot of time on that one. So that's why you're going to see that -40 degrees Celsius is the same what? Temperature on the Fahrenheit thermometer. It will have the same reading. Okay, the next question says, the heat needed to warm 8 kilograms of water from 20 degrees Celsius to 70 degrees Celsius, the heat needed. So that means I'm going to go to my equation for heat transfer. Q equals mc delta T. Okay. Now, what is mass? 8 kilograms. So I put out 8 kilograms. What is C? Remember, C is the specific heat capacity of that substance. And my substance is water. And that's the one I asked you to know. So for water, we're going to use 4.2 kilojoules per kilogram degree Celsius. Okay, that is my C. C stands for the specific heat capacity of that substance. And then delta T simply means what? Temperature final minus temperature initial. So I've got 70 minus 20, and that gives me simply what? 50. So when I do all the work, 50 degrees Celsius, so that'll cancel out. The kilograms will also cancel out. So my answer will be in kilojoules, and just a matter of multiplying those numbers. So I have 8 times 4.2 times 50. And I do that and I get 1680. So 1680 kilojoules. So now if I was turning my work in, I would say 1 is C, 2 is B, 3 is A, 4 is C. Okay. Now let's look at the other two. We have 3 more. Okay. The specific heat of ice. So now we have a new value for the specific heat, and this time it's ice. So they say it's 2.1 kilojoules per kilogram degree Celsius. Now, when 50 kilojoules of heat is removed, so I want you to understand that the kilojoules, the 50 kilojoules of heat, that's my Q. Q stands for heat exchange, is removed. So now, class, you want to make sure that you have a negative here. Because when we add heat energy, it's positive. When we remove it, it's negative. Okay, removed from a mass of 2 kilograms, initially at, so my temperature initial is -5 degrees Celsius. And now they want us to find the final temperature. So on this one, what you want to do, let me just put some space here. Oops, hold on. Okay, I'm going to go down to right here to solve the problem because I cannot work it out well in this little limited space. So right here. So you know that, hold on. You know that Q equals mc delta T. Now, the first thing you want to do is get delta T by itself because that's where T final is. Remember, we know that change in temperature always means T final minus T initial. So therefore, we have to get that by itself. So my next equation then is delta T equals Q divided by MC. Now, let's break down delta T. In other words, delta T itself is T final minus T initial. So the equation we're going to solve is the one that says T final equals Q over MC plus what? This is negative on this side of the equation. When it goes over to this side, it becomes what? Positive, T initial. So now I know Q, I know M, I know C, and I know T initial. So let's plug these in. Remember, Q is negative. So I have negative 50 kilojoules divided by M. I'm sorry, let me finish up Q. What is Q, class? Negative 50 kilojoules per kilogram degree Celsius. That's all that is Q. Divided by M. What is M? M is what? The mass, right? So we're going to have what, class? We're going to have, what was that? What was the number? 2 kilograms. That's our what? That's our mass. And then we have to have C. So what is C? C is 2.1. Okay. Oh, this is incorrect. That's what I was thinking about. Oh, forgive me. Kilojoules was that. This is what I was trying to put in. C. C is 2.1 kilojoules per. Remember we said when we're going to do per, it has to go where? To the numerator. That's why I was seeing a problem. Okay. Q, 50 kilojoules negative. Mass in denominator, 2 kilograms. C in denominator, 2.1 kilojoules per kilogram degree Celsius. Plus T initial, negative 5 degree Celsius. So now we can see that our unit needs to be in degrees Celsius. That's the first thing we see even from our answers. So kilojoule and kilojoule will cancel, and kilogram will cancel. So the unit remaining is only going to be degree Celsius. So I find this number, which is negative, and add to this number. So what do I get? I've got negative 50 divided by 2 divided by 2.1. What do you get? 50 divided by 2 divided by 2.1. And we get negative 11.9. So my T final is going to be a negative 11.9 plus negative 5. And all of this is degree Celsius. So I'm going to get, what's that? Negative 16.9. Negative 16.9. So we're going to choose D. Let's see if I have a question. Hold on. Okay, very good. Okay, very good. All right, let's move on now to a couple of more, and then I'm going to let you go do your quiz. This one says, when 90 kilojoules is removed from a 2 kilogram copper bar, its temperature drops from 200 degrees Celsius to 85 degrees Celsius. So let's do this one. I'm going to try a different color, see what happens. Let's see. Okay, just see what this color looks like. Okay, so remember, the heat is removed. So I'm going to say 90 negative. Okay, negative 90 kilojoules. Why? Because it is removed. My mass is 2 kilograms. My temperature drops from 200 285. So that means that my initial temperature is 100 and my final temperature is 85. And in this case, then my delta T is negative because I'm subtracting a smaller number, a larger number from a smaller number. So I have negative 115. You see, delta T can be negative. So I have negative 115 degree Celsius. And it's asking me to find the specific heat capacity. So that means I take my equation. I'm going to go right here so you can see the difference. I'm going to go right here. And we know that because Q equals MC delta T, this implies then that C is going to be Q divided by M delta T. Now, because Q is negative and delta T is negative, we know our answer is going to be positive, which of course we see over here. So all we got to do now is put these numbers in our calculator. Okay, what is Q? Q is negative 90. So I've got negative 90, but of course I know it's going to be positive. I just put in 90. And I'm going to divide it by M, and M is 2. And I'm going to divide it by 115. When I do all that, I get 0.391. Now, 0.391 what? Q is in kilojoules. M is in what? Kilograms. Delta T is in what? Degrees Celsius. So therefore, I'm going to get 0.39 kilojoules per kilogram degrees Celsius. So there I have what? My answer. Okay, last one. How long will it take for a 2 kilowatt heating element to raise the temperature of 30 kilograms of water from 20 degrees Celsius to 80 degrees Celsius? So again, what are we given? We're given because it's watts. So it's 2 kilowatts. Raise the temperature of a certain mass. Our mass is 30 kilograms from 20 to 80. So therefore, we can easily write down delta T. Delta T is 60 degrees Celsius. And we're looking for time. So remember, that's our power equation. And we said that power is heat energy over time. So this implies that my time is going to be what? Heat energy over power. So my time is going to be Q, which is MC delta T. So we have MC delta T, that's what Q equals, over power. Now, what is M? M was given as 30 kilograms. What is C? Well, it says the temperature of what? So much water. So therefore, we're going to use the specific heat capacity for water, which is 4.2 kilojoules per kilogram degree Celsius. What is delta T? Delta T is 60 degrees Celsius. And all that's being divided by power, and power is 2 kilowatts. So first we make sure that we have a joule per watt, which we know is a second. Let's make sure kilograms and kilograms cancel. Degrees Celsius cancel. Kilo cancels. We end up with a joule per watt. A watt is a oh, pencil quit. Hold on. A watt is a joule per second. So therefore, this answer will come out in seconds. So now we put in a calculator. We have what? 30 divided by 2 is 15. Let's just do 15. We have 15 times 4.2 times 60. And we get 3780. So we get 3780 what? Seconds. But our answer needs to be in minutes. So we divide our seconds by 60. And we get 63. We get 63 minutes. So that's our answer. Okay, so now I've taken the time to do a quick review. I hope you were paying attention. If you want me to go back to this page during the quiz, if you want me to pull up anything, I will. Because on this, using this form, it doesn't go away. All right, are there any questions on any of these problems? Any questions? Okay, if there are no questions, I'm going to put up the quiz. The quiz has a couple of thought questions, as well as it has the problems. Okay, so let me go find the quiz. Hold on. Do a new share. First of all, are there any questions? I'm making sure there are no questions before I go to the quiz. Okay, let's see. All right, very good. Okay, so let me go now to.
Any questions? Is this
Here,
quiz?
I think it's 9. I think there are 9 questions, about 7 problems like we did here, and a couple of thought problems. And I made it a little easier than this one. I hope it is at least. Okay, so here we have question number 1. You're converting from a typical, well, this is a question we went over yesterday, so you may even know the answer, but look at that question carefully. Number 2, number 3 is a conversion number 3 is a conversion between Celsius and Fahrenheit. Number 4 is a conversion. Number 5 and 6 are just questions for you to understand. This is another temperature problem. And then we have 8 and 9, looking for specific heat capacity and the final temperature. So I'm going to leave this up. I'm going to let you see the first 3 problems, and you tell me when you're ready to move on to the next set. So it's 157. Those should be very quick. I'll just go to mute and let you work on those.
Do you want to type in first answers, or just wait till we have all the answers?
Right, just write your answers down, and you're going to submit your answers at the end of the quiz.
Okay, thank you.
Mhm. If you want to skip some and go to the others, I can always pull it back up again. If you want to just say, I want to do these first 3, then let me do 7 and 8, ever how you want to see it, just let me know. Someone asked me to go back to 4 and 5, so I'm going to show those again for a few minutes, and then I'll move back up again. Okay, so I'm showing you the answers. You can see what, if your answers agree with any of these. If you have any questions, say those for Monday, since we are out of time. But I think most of you did really well. I was hoping that on this question number 9, that once you wrote everything down, you would see that this is in grams and not kilograms, that this is in calories and not joules, and that you would make the appropriate conversions, which I think most of you did. I think I saw 70 degrees Celsius for most of your answers. So with that being said, I think you all did pretty good. And what we'll do on Monday, after I finish grading these, I'll go over the ones that you have questions on. With that being said, if you're still here, you can go ahead and sign out, and we will. Okay, I wanted to show number 8 real quickly. Someone did have a question on number 8, so give me a minute at least to show number 8 real quickly, so they won't be worried about it all weekend. Let me show you. Let's get my pencil, my pen to work. Pens. Okay, so number 8 here, you're looking for the specific heat capacity of the metal. So you know that Q equals MC delta T, and this implies then that this C, which is what you're looking for, is going to be Q divided by M delta T. So that should give you the answer, because you know Q, you know delta T, which is just 20, and you also know M. So if you do all that, you should get C, which is the specific heat capacity of that metal. Okay, well, you can sign out, and I will see you on Monday. Have a blessed weekend and enjoy yourselves.